So hello everyone, we are here to present you the project Jacques Vert. We'll start with a quick introduction and then we will present you the original game and the modifications we've made to it. So our project Jacques Vert is based on the serious game which integrates a participatory simulation of waste management. So it means that players will be able to influence the simulation with their actions. And Jacques was created in a special context with the M2 internship of Léo Piré, a geography student at ENS Lyon, interested in power dynamics emerging during participatory simulation and in waste management conflicts. The game was used with local political leaders, village chiefs, and farmers. And the objective was to encourage cooperation and communication between players on local public policy issues. So here is a photo of a game station to help you visualize the game setup. And we will come back to the game in detail in the next section. Our project is to adapt this serious game, so Zach, with a VR component to a younger audience from the students from 10 to 12 years old, with different objectives from the original game. The first is to raise children's awareness on household waste pollution and its impact on the irrigation system, and also to provide opportunities for teachers to use the game as a teaching tools. And we kept as it will be used in classroom, accompanied by educational supervisors. And we kept the essence of the original game and kept the cooperation and communication in the game. The addition of virtual reality firstly adds a fun and attractive value to the game that may raise students' motivations to get involved in the activity. And secondly, provides an immersive experience in a virtual world and that allows players to see firsthand the influence of their actions.
So I'm going to explain you how Zach works, even if I think 90% here already play at the game, but I will explain. So the game is played by 4 teams of 2 or 3 players. Each team is associated to a village, to one village, and all the village form a commune. There is no competition between the players. They must cooperate because the aim is to win the eco label, so they have to win together, and they can't win alone, and so they can play alone. They get the eco label when the level of pollution is below a certain threshold, like you can see here, while they're keeping a sufficient level of production, of agricultural production to make action. So the aim is inspired by a real problem faced by farmer communities, Vietnamese farmer communities. It's obtaining the Viet Gap. It's a real quality label, which gives them the possibility to have an access to a larger market, like a supermarket in city, etc. So the initial situation of the game is supposed to be critical. It's supposed to be critical. They're gonna lose the eco label, so yeah, the eco label will be withdrawn from the commune. So we think the game has therefore been designed to encourage the cooperation between all the players with the group and between all the group to keep this label and have more money. To manage their territory and keep the eco label during all the game, each village is able to do some predefined public policy actions, which have some various effects. They can be used according to the budget obtained from their agricultural production. So, as you can see here, if they are on the threshold, they have more production or less. So the actions are presented on physical cards with a QR code. So the game takes place over several rounds, and each round comprises several phases. There is an action phases, a discussion phases, and a simulation phases. Simulation phase. During the discussion phase, they need to choose themselves what card action they're gonna use. So they need to be agree with all the people of the other groups, because if you always play the same card, or if all the group play the same card, they're gonna lose or not. The discussion phase, they need to choose that. The action phase, they just validate the card that they already chosen, and they can give the remaining money to one of the group, one of the village, if there is a remaining money. So a village can make another action. And the simulation phase, the model takes into account the action and simulates the territory evolution over the year. So they can see if they still have the ecolabel at the end or not. And as we have said, the game has been designed to encourage people to discuss together and make collective decision, because they really can't win alone. And even if the cards have to be chosen by each group, they really can't win alone. So that's all.
So I'm going to explain briefly the simulation. So each village has fields, urban areas, and landfills, and they are crossed by river sections. And the simulation is updated with a daily steps composed of 4 stages. So first, the pollution production by people, the pollution diffusion by rivers, pollution decrease, and agricultural production. So the first stage, the pollution is produced by 2 types of people: the inhabitants that produces household pollution, and the farmers who produces agricultural practice pollution. And there are 2 types of waste: solid waste and wastewater. The pollution is discharged underground or in the river. And the second step is the pollution diffusion by rivers. And during this stage, the waste in the river is transported along the river. Concretely, every river section, for each river section, a part of the solid waste and liquid waste is continuously sent to the next. The pollution decreases also naturally a bit, so the 2 types of waste. And also it decreases thanks to waste collection. There are 2 teams. There are teams of collection who collect waste 2 times per week in urban areas, and it's only solid waste. And the last step is the agricultural computation, and it depends on the use of inputs or the limitations and the surrounding pollution.
All right, so now we'll show you how we adapted the game to add some VR in it. So first, here are the main changes. So first we had to change our audience. So now the audience is way younger, so we have a target of children between 10 and 12 years old. So we had to adapt our design to that kind of players. Then we made small adjustments of the simulation by removing the landfill because without you, it was useless in our case. And obviously, we added a game phase in which the player can use VR. So to make that, we changed the way the cycle of the game. So after a year of simulation, one player is chosen to explore the world. And during this phase, this player gets to go into a small world that represent the simulation. And we ask the player to guess what different levels of pollution are based on some indicators in the VR world. Also, during this phase, so there is only one player by team that is using VR. So the other players can communicate with the player, and we thought of a different interface when one player is in VR, the other player can see a minimap of the environment, and so they can see where the player is, and they can guide him to different points of interest in which there is some indicators of the pollution and the production levels. And so we also adapted the general interface of the simulation. And one of the main changes we did is we can no longer see what village is producing pollution. So now the levels are general. So this way, it's mandatory for the player to tell what he has seen in the VR world, to know what amount of pollution is in each village. And then in the discussion phase, different players have to share what they have seen in the VR world, and to guess, for example, what village had the biggest amount of pollution, for example, solid waste. And then by knowing that, the players can take decisions based on these indicators. And now I will explain a bit of our process to build this world. So these are the main phases. So we made a concept of the environment. We thought of the environment. The main goal was to make an environment that had every pieces of important factors to show, like the rice fields, the water pollution, and we wanted to have small part of the village and part of the natural environment, so we can see every part of the pollution. And then from the concept we made, I did 3D modeling and texturing to build the world, and then we integrated it into Unity. And a quick thing. So we had to link Gamma with Unity, because before the game was only running in Gamma, and now we had to make a link between Unity and Gamma. So the simulation is running in Gamma and sending some informations to Unity. So we have 5 classes of water waste and solid waste, and we have 3 classes of production. And these pollution factors are displayed in Unity by showing some more waste or changing the colors of the river, for example. And then it's not yet implemented, but we want to send back the position of the player in the world, so the players can see where he's in the minimap.
So to build the world, we work together with Eloi to go from general concepts to specific assets and the location we wanted to represent in this world. So in order to do that, we both gathered a lot of references from the Vietnamese countryside to have the more realistic stuff to make a clear universe that will talk to our public. So we started after that to draw the location that would end up in the game. So about the process, when the idea was fixed, we start by making this map. So it's a draft map to just play the elements needed and the most significant, as Eloi explained, like a riverbank, fields, some houses, some vegetable garden, and all the elements to be significant for see the pollutions. So the draft map is also used to clearly define the path to be followed by the player, and also what we want them to do and what we want them to see. There is no obvious way to follow, and we really wanted to let the player free in their own experience, and they will see what we want them to see, but they can explore and they can sometimes takes time to see things on their own way. They can't miss the significant elements, and we have tried to put at the same place without being too unrealistic. Maybe it doesn't exist, but it's helpful. Without being too realistic, and all the elements that are significant enough to make the game work and the message clear. So after that, Eloi started the block out. So it's a 3D map where he built the first version of the map where we could feel the scale of the map in virtual reality. And from that block out, we decided what the different location would look like. At that point, Eloi starts modeling the environment in Blender. So it's a 3D software. And I continued concepting the different assets. We slowly completed the environment and adding more and more details. So for example, it is some painting, some concept and some assets for the vegetable garden. And this is the translation in 3 dimension in the Zach world.
And so here are some screenshots of the game, but we'll make a quick demo so you can see better. So yeah, some of the world, but we'll come to that after. And so yeah, a big challenge also was to display the pollution. So we had the different levels sent to Unity, and we had to display them in from Gamma to Unity. And it's not final, but we made a lot of waste type. For example, the different plants are changing colors, and as well as the river. So we'll see that in the demo too. And finally, a bit of what we want to do next. So first of all, we would like to try to have NPC interactions. It's a bit of a technical challenge, but we will try it. And this way, the NPCs could talk to the player and give him some information about the production and the pollution. Next, we would like to be able to have multiple headsets, because for now the demo is only running on one single headset. And we also would like to enhance the play cards, because we haven't touched it for now. And also, it's always we want to enhance the world map and the 3D world if we have time to do it. And finally, we would like to do playtests because we haven't tried it on the children, so it would be really interesting, and maybe some of the things have to change because we don't know how they will interact with the game. So that's it for the presentation. Now we'll make a demo of what we did.